Okay, so how about those logarithmic equations? The second half of your assignment deals with those, which can be a bit problematic, right? But here's a nice little trick here. I'm going to take those and I'm going to classify these problems into two different sets. Take a look at just the left side. Look at all these. What do all these have in common? Yeah, if you notice the equal signs in all those, the logarithms are all on one side of the equation. When you compare it to the right column group of problems there, notice the logarithms on both sides. I want to focus on these ones where the logarithms are on both sides for a second. What do you notice about the logarithms that are on both sides? On each one of these three equations, notice that the bases are the same. So I'm focusing on these ones first just because it's pretty quick work to set these problems up and solve. And let's just do one of them. Because this top one up here, because the 2 and 2 are the same there, wouldn't that also imply that 7x plus 1 must be equal to 2 minus x? It sure would. So if that's the case, then we can just solve that problem and just solve 7x plus 1 being equal to 2 minus x, and just solve for x. Let's add x to both sides. Let's subtract 1. And then divide. There's our solution. And guess what? The rest of these problems are going to go exactly the same way that we have over here. 3 minus 4x would be equal to x over 3, and 7x would be equal to 2x plus 0.5. Now what about these ones? This one's going to require a little bit more steam. Let's focus on the first one right here. Let's focus on the base 3 log of x minus 5 equals 2. This is actually the first problem on that note sheet of yours, example A. I want to show you something here. Look familiar? Yeah, this was the fluency that I wanted you guys to see when you guys are looking at these problems. So when you notice that you have a log on one side and the base is 3, notice that we can change this into an exponential equation pretty easily, right? If we have those three things right there, what's that going to look like? Isn't it going to say 3 squared equals x minus 5? And if 3 squared equals x minus 5, doesn't that also mean that we have 9 being equal to x minus 5? And we can solve this problem. Just add 5 and put it on the other side. Is it a big deal to check our answer? Heck no. Put a 14 in there. 14 minus 5. That's 9. The base 3 log of 9 equals 2. Isn't it true that 3 squared would be 9? Sure. Yeah. So this is what you're after here. You need to find some way, somehow, some way, when you're looking at these problems here, where the logarithm's on one side, to be able to go from here to there. That's what you're after. Notice we were able to do it right away on this problem because we had a single logarithm here and we were able to set it up with those three things here. Look at the second example there. Are we ready to use this? I don't think we're ready to use it. But what could we use here first to turn it into just a single logarithm on this side of the equal sign? You got it. Why not, if we have two logarithms being subtracted, let's divide them. Let's divide them. Let's divide what exactly? We're dividing the 45x divided by the 3. So 45x divided by 3, that gives us 15x. So the log of 15x equals 1. Are we ready to use this up here now and change everything to that stuff over there? We are. Wait a second. What was the base here again? Ah, yeah, it's 10. So isn't this really saying 10 to the first power equals 15x? And isn't this just 10 then, because 10 to the first is just 10. So how do I solve this problem? Divide both sides by 15. 10 out of 15, isn't that 2/3? There we go. Let's look at the third one right here. Is this ready to go? Up here? Yeah, how can we tell? We didn't have to do the division move because we only had one logarithm here. So B, and this is going to be our x value here, and there's our a right there. So we change all those three things here. There we go. 4 to the 7th power has to be x squared. You could have used the log property, I get that. That could have worked. What's 4 to the 7th? 16,384. Now how do I solve for x here? Notice it's a little bit different. X is now a base. So now it's time for a square root, isn't it? So you get the square root. We got to check both those answers. Notice with the positive case in here. And why am I really stressing checking answers here? Is because we ended up with a negative number in here. One thing to keep in mind is that you can't take logarithms of negative numbers. Do you notice why we're okay with this particular negative number? It's because we're squaring it, right? Negative 128 squared would be a positive number, so we're going to be taking a base 4 log of a positive value no matter whether that 128 is positive or negative. So we should be okay there. All right, let's focus on the final problem here. This one's a little bit squirrelier than the other three. Notice double logs, right? With a plus sign here. So yeah, instead of dividing, now we're going to multiply those together. What would that look like? Looks like something like that, right? X times x plus 9. Distributive property. Simplify it there a little bit. And oh yeah, look what I did there. Actually, I didn't do the distributive property just yet. I kind of looked at it like this. Would the distributive property been okay? Sure. And treat it as x squared plus 9x right away. But remember, you still have that invisible base of 10 to the first power equals that. Now, there I go, I distributed it. So x squared plus 9x. How do I solve this quadratic? Oh yeah, set it equal to 0. Thanks, Boromir. So if I set that thing equal to 0, remember that's positive 10, I got to subtract 10 from both sides. And Boromir tells us setting it equal to 0. There we go. So now what do we do? Yeah, this is a nice little factor job. And we got to come up with two numbers whose product is negative 10 and their sum is 9. Right? It's got to be a positive 10 and a negative 1, which will give us two solutions here, right? Negative 10 and 1. Whoa! All right. Thanks, intimidating baby. Check our answers. Negative 10 in there, going in here, and also negative 10 right there. Remember, be careful about those negatives. Sometimes it works, like we saw earlier, but notice what happens right here. Wah, wah. So guess what that means? If we get an error, that means that answer is no good. So the only answer that is legit here is going to be that 1, and you can check it in there. Okay? Happy hunting. Go Tigers!